Okay, so some other uh, elements that you could describe um, if you were asked, if we were trying to answer the question, what is a photon? We could talk about how photons were created. Uh, we haven't talked about this yet. We will be talking about it in the coming weeks, about how atoms have distinct atomic orbitals, electronic orbitals, and you can basically create light by inducing transitions between those orbitals. You can and so you can create photons which then propagate. There's other ways to create photons. Another famous process, which is actually in the book but we haven't talked about, is Bremsstrahlung, where basically electrons, high energy electrons that decelerate when they impact, they go through material and basically interact with the atoms, the positively charged nuclei in the atoms. As they decelerate, that's a charged particle that's undergoing an acceleration, they can emit photons. They can emit photons, and so that's another way to create light. We could talk about how their fundamental role in physics, the fundamental role that they play in physics, which is sort of deep. They actually they are responsible for transmitting and the electromagnetic forces between particles. So, for example, two electrons, we know two positively charged or two negatively charged particles will repel each other via what we call the Coulomb force. But that Coulomb force, in a quantum mechanical way, is actually mediated by a particle, and that particle is a photon. Okay, and so as charges push on each other, this actually corresponds to an exchange of photons. Okay, and finally, we could talk about their composition. We could try to talk about their composition, but in fact, photons, this is just not known. People don't know what makes up a photon, and in fact, to all appearances, for any experiments that we're able to do so far, photons are basically point particles. They are fundamental particles that can't be broken down into constituent components. And so this is also true of some other particles. For example, electrons are thought to be fundamental particles with no internal structure, no internal composition. So, but we really don't know that. We don't have any experiments where we can really test that at the moment. Maybe the most difficult question to ask as part of what is a photon is, or the most difficult question to answer is it a particle or is it a wave? Again, we've seen that photons, light somehow behaves differently under different circumstances, and particles and waves have very different properties, right? So particles, for example, fundamentally they deliver their energy. If you have some particle that's traveling and then it impacts with something, it transmits some energy upon that collision or that impact, but it does it all in one lump. Okay, and so that's a characteristic of a particle. Waves, on the other hand, the energy of a wave is spread uniformly over the entire wavefront. Okay, wavefront meaning, well, you can think of sort of a water wave. The wavefront is just where the crest of the wave, or the trough of a wave. So as this wavefront propagates, basically the energy is distributed along the whole wavefront. Okay, so that's obviously, those are very different things, and we've seen again that sometimes photons, sometimes light has particle characteristics and sometimes has wave characteristics. So we've got a little bit of a dilemma, a paradox, and in order to resolve this paradox, to answer this dilemma, to address this dilemma, we need to do an experiment. We need to figure out an experiment where the expected outcome will be very different if in fact we have particles or if in fact we have waves, and then that helps us answer this question. And the right experiment to do, the most fundamental experiment and the simplest experiment to do, is the classic double slit experiment, which we'll talk about now.